students, and welcome back to our next segment in the topic of weather. If you recall, yesterday we learned a little bit about some general ideas of weather. We defined weather, but we left some more details for today. And so we've got a lot more information to cover today, and we'll finish up our notes on this day. And I just have to say that the answer, my friend, is blowing in the wind. The answer is blowing in the wind. So, wind, let's pick it up with wind here, ladies and gentlemen. And we'll begin with the definition of wind, talk a little bit more about it, and then we'll get into more specifics about weather today. So, what is wind? Well, how many of you have ever felt the wind blowing on your face? Everybody has at one point or another. Now, you can't see wind. You can't taste wind unless there's something in the wind blowing into your face, but you can feel it. Even though you can't see it, you can feel it. But have you ever thought about what is wind? And there was a little fuzzy on my glasses blowing in the wind. So what is wind? It is the movement of air or air movement from one place to another that is due to the differences in air pressure. Now, if you recall from yesterday, we talked a lot about air pressure and the factors that affect air pressure. Well, wind is the movement of air due to differences in pressure. And these differences in pressure ultimately are the result of the unequal heating of the Earth's atmosphere. Let's see if I can think of an example. How many of you brushed your teeth today? I hope you all have. And I would imagine most of you probably used a tube of toothpaste, right? Well, how do you get that toothpaste from the tube to your toothbrush? Well, you open up the cap and then you squeeze the tube. When you squeeze the tube, you are increasing the pressure on the back of the tube. And what's the result? Well, that toothpaste oozes out of the tube. Why? Well, it's moving because of a difference in pressure. Pushing it down on one end will result in the movement of that toothpaste in the opposite direction. It's very similar with wind. When the air pressure is higher in one place and lower somewhere else, it's going to result in the movement of air from one place to another. We call that wind. If you watch a weather report, which I hope you are this week, when you watch a weather report, you'll see a big H and a big L somewhere on the weather map. The H stands for high pressure, the L stands for low pressure. If you look at the relative positions of H's and L's on a weather map, you can be pretty much guaranteed that the direction of the wind is going to be from the H to the L, from the high pressure to the low pressure. That's how wind moves, from high to low pressure. So now we said there are different kinds of winds. So let's talk a little bit more about two specific types of winds. The first type of wind is called the local wind. Local wind, my ear was getting a little bit wet from this doggy trying to put its nose on my face. Aw, you're so cute, doggy. Oops, you're so. Where are you, doggy? You're over here. Okay, let me dry my. Okay, local wind. Local wind takes place over short distances. Now, really local wind you've observed, like this dog has observed by putting its face out the window. But that's not really the type of local wind we are describing here in weather. What local wind really describes is something you may have experienced if you've ever gone to the beach. Let me try and explain this to you. First of all, how many of you have ever been to the beach? If you've been to the beach, you'll be able to get this a lot easier. There is something called a sea breeze, which flows from sea to land. But I want you to look at the arrows here, and I want you to listen to the story I'm about to tell you. If you've ever been to the beach on a hot summer day, maybe you were on the boardwalk or at the parking lot or wherever it might be, and you come running down the sand to the water because you want to take a swim. How would you describe your bare feet on the sand in the sun? You probably would use the word hot. If you've been to the beach on a hot summer day, sun is shining, you got bare feet, you're walking in the sand gets hot. Now think about air pressure yesterday and how we related air pressure to temperature. If the relative temperature is hot, what happens to hot air? It rises. And as hot air rises, what happens to air pressure? As it goes up, air pressure decreases. So hot air rises, rising air creates low air pressure. Let's think about that. Now, if you jump into the water, generally speaking, is going to be, during the summer at least, is going to be relatively cooler than the hot sand. You jump in the water to cool off your feet. Well, that cooler water cools the air above it. And cooler air, unlike hot air that rises, cool air sinks because it is more dense. Sinking cooler, denser air is going to have a high pressure area. So we have a relatively high pressure over the water, a relatively low pressure over the land. High pressure, low pressure, which way is the air going to flow? From high to low. And so that explains what a sea breeze is. If you're ever at the seashore in the middle of the day on a hot summer day, you will undoubtedly be cooled down from the sea breeze because the breeze is going to be coming from the sea, from the high pressure to the low pressure. Hopefully that helps you understand the sea breeze. Now, the opposite of that happens at night. If you've ever been to the beach at night, you may have gone barefoot in the sand and noticed that the sand is really cold. That's because sand heats up and cools off very quickly. When we get to physical science, you'll understand why when we learn about specific heat of different substances. But for now, you just know that sand cools off quickly at night. And because of that, the cooler sand produces an air mass above the sand that is cooler. It's going to drop, and it's going to have a higher pressure. The water, on the other hand, at night, relative to the beach, is going to be warmer. And so that warm air mass above the water will cause that air mass to rise because of a lower density, lower pressure. So now we have at night high pressure on land, low pressure over the water. Which way is the air going to flow? It's going to flow from the land to the sea. So we call that breeze a land breeze. So I have a question for you. Think about these two scenarios again, a sea breeze and a land breeze. If you were flying a kite during the day, which way would you expect the kite to be blown? Toward the land or toward the sea? And conversely, think about if you were flying a kite at night. Would that kite fly over the sea or over the land? That might be a good quiz question for you to think about. So I'll let you think about that for the rest of the week. All right, let's move on though. All right, so we talked about local winds. Now let's talk about global winds. Local winds can affect the local weather in an area, but global winds affect regional weather over a large area. And so global winds take place over long distances. And when we say long distances, we're talking about the entire planet. If we were to look at this map, for instance, you can see the picture of the entire globe here. And I want to point some things out on this globe. Next week, when we get to climate, we'll talk about the actual wind patterns that affect climate over a long period of time. For now, just notice a couple things. First, here at the equator, we see these red arrows to the orange arrows. This is like a cross section of the atmosphere. And I want you to picture this, that the sun is beating down on the equator. And as a result, it heats up the air and the air rises. These arrows over here on the right are illustrating a cross section of the atmosphere. So this would be the surface, and this would be high in the atmosphere. So the direction of airflow in the atmosphere is up from the equator. As hot air rises, it starts to cool down and will eventually sink as cooler air. And we get what's called a convection current. This number 1 is representing the convection currents in the northern hemisphere that we refer to as the northeast trade winds, because on the surface, that's the predominant direction of winds from the east to the west. But back to the cross section, this cooling air will eventually warm up again at the surface and rise again, and creates a secondary cycle of airflow, this convection current in the region of number 2. And this is the region we live in, and it's called the westerlies. The westerlies have winds that are predominantly from the west. Guaranteed, if you watch a weather report this week and you watch the weather map of the entire country, you will see that our weather in the United States typically goes from west to east, because that's the predominant direction of airflow or the wind at our latitude. And then finally, the third major convection current, it has to do with the polar highs. And we've got another direction of airflow in the north and the south polar regions. Again, we're going to pick this up a little bit more next week when we talk about climate, but understand that there are global wind patterns that result from general global uneven heating of the Earth's atmosphere as well. All right, now we're still on the topic of wind. Let's talk about the instrument used to measure wind speed, and it is called an anemometer. Look at that word and say it with me. Anemometer. An anemometer is an instrument used to measure the wind speed. And this can be very useful information for a meteorologist or someone who studies weather and gives weather forecasts, because knowing the wind speed can tell you a lot about the differences in air pressure from one pressure area to another pressure area. The bigger the difference in air pressure, the faster the wind will flow. So an anemometer is an instrument used to measure wind speed. All right, let's transition now to moisture in the air. As you've been watching weather reports this week, I'm sure you've heard of different words being used in addition to temperature. You've probably heard the word humidity. So what is humidity? Well, relative humidity is a measure of the amount of moisture in the air. Our lab activity tomorrow is going to measure the humidity in the air in our laboratory. We're actually going to measure the relative humidity in the laboratory. And it'll be pretty cool. We'll wait till tomorrow to get to that. But there is an equation that we're going to use to help us measure that humidity. And it is this: the percentage of relative humidity is the amount of moisture in the air divided by the moisture that the air can hold. If you think for a moment of the air as a beaker or a container, that beaker or that container might be able to hold a certain volume of water in it. The relative humidity is how much water is actually in that container of a certain size. So again, the percentage of relative humidity is equal to the moisture that is in the air divided by the moisture that the air can actually hold. Now, to measure this tomorrow in the lab, we're going to be using an instrument called a psychrometer. A psychrometer is an instrument used to measure the humidity, also known as the water vapor in the air. And with tomorrow's lab, we'll be explaining exactly how to do this, but it basically involves swinging two thermometers around very quickly. Stay tuned till tomorrow to find out more about how a psychrometer is used to measure the relative humidity in the air. Let's go now to clouds. This is a manifestation of humidity in the air, because when that humidity actually condenses in the atmosphere, well, we see that in the form of clouds. Clouds are a collection of condensed moisture in the air, and that moisture condenses on microscopic dust particles. Yes, when it rains, rain is dirty. If you've ever opened your mouth while looking up in a rainstorm or during a snowstorm, every drop or every flake that falls to the ground has a little dust particle on the inside of it, because that's how either rain or snow, any type of precipitation will form. It forms on microscopic dust particles. If the atmosphere were perfectly cleaned with a HEPA filter and there was no dust at all, it would never rain. There would never be clouds in the sky because, well, the air would be perfectly clean and nothing to condense on for the water vapor. I wouldn't mind that. I would love blue sky and sunshine every day. That would be pretty cool. But not all clouds are the same. There are many different types of clouds that a meteorologist will study. We can see from this poster here, there are different prefixes that can be added to cloud names, such as cirro, which refers to high altitude clouds. Cirro is a word that means a wisp of hair. Alto, given to mid-altitude clouds. The word alto means high. Nimbo is a word, it's a prefix, or it could be nimbus if it's a suffix, is used for clouds that bring rain. And stratus refers to a layer and means a flat, wide, layered cloud. But there are many other combinations here of these prefixes and suffixes that come together. We're not going to learn about all the different kinds of clouds because there could literally be dozens, if not hundreds. If you were a meteorologist, you'd study all the different types of clouds. We're just going to focus on a few, starting with cumulus. Cumulus clouds are like the most common clouds that are drawn by little kids everywhere. If you were asked to draw a picture of a cloud on a piece of paper, you undoubtedly would probably draw something that looks like a puffy piece of a cotton ball. That is a cumulus cloud. Cumulus is a white, tall, and fluffy cloud, usually an indicator of fair weather. But there are variations, like when you start adding nimbo or nimbus to it, those could be nasty rain clouds. What a beautiful picture here, by the way, of Bryce Canyon with these beautiful cumulus clouds. So cumulus, in addition to writing down the description of the cloud, might be a good idea to draw an illustration of the cloud type itself. Next, we've got stratus. Stratus are typically gray, flat, and layered clouds. Again, the symbol on a weather map would be three wiggly lines put together, layered clouds. So stratus clouds, gray, flat, and layered. You can see in this picture here, this is a stratus cloud above the seashore. You don't really see much definition with a stratus cloud. Here we have cirrus clouds. Cirrus clouds are feathery, high, and wispy, and little cotton balls by the sunshine would illustrate cirrus clouds. So we're only going to focus on those three here for today, but I want you to remember once again that we can add lots of prefixes and suffixes to these names and other names for that matter in order to come up with a whole variety of different types of clouds that are typically good predictors of not only what the weather is right now at the moment, but the future type of weather that could be on its way when you watch a progression from one type of cloud to another type of cloud. That can give you a lot of very useful information. Now, what do clouds bring? They bring precipitation, and not all precipitation is the same. We're going to talk now about 5 different types of precipitation. And as we talk about each of these types of precipitation, I'd like you not only to write the word down, but a combination of 3 words next to the type of precipitation, which will help us visualize and understand the type of temperatures at a high altitude where the cloud is forming, at a mid altitude as the precipitation is falling, and at ground level. So when the air temperature up high where the clouds are is warm enough that there's liquid condensing to the dust particles, and that temperature remains warm as the precipitation is falling and remains warm at the surface, we call that type of precipitation rain. It's the most common type of precipitation around planet Earth, and that's how it forms when the entire air column, top to bottom, is warm. And by warm, we mean above the freezing point of water. If it's warm, top, medium, and bottom, we've got rain. So rain can be described with the words warm, 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 again, representing high, medium, low altitudes, or the altitudes at which the cloud forms, precipitation falls, and the altitude at the surface, essentially. So warm, warm, warm are the 3 words to write next to rain. So let's go to the opposite one now, snow. I know some of you love the snow. The older I get, the less I like snow because I have to shovel it, and I don't like shoveling snow. But in order for snow to fall, the 3 words for you to write down are cold, cold, and cold. It's got to be cold enough in the cloud for the water vapor to freeze. It's got to be cold enough in the air for those frozen crystals to remain crystallized. And it's got to be cold enough at the surface for the snow to remain snow when it hits the ground. So the 3 key words for snow, cold, cold, and cold. But it doesn't end there. There are 3 more types. Sleet. Sleet is interesting because sleet forms when it is warm enough in the atmosphere where the clouds are forming that it rains. But as that rain falls, it's cold enough as it's falling to freeze that water droplets or those water droplets into ice, and it's cold enough at the surface that the precipitation will fall as little ice crystals, and we call that sleet. So the 3 words, warm, cold, and cold. The next one is hail. This describes typically the most violent type of storms at all. And hailstorms can be pretty dangerous. The three words are cold, warm, and cold. And now let me explain this, because high in the atmosphere where the clouds are forming, and usually this could be done in nimbostratus clouds, but nimbocumulus clouds, fluffy clouds that are really high and produce precipitation. But in these types of clouds, it's cold enough that the precipitation is crystallized. However, because of a change in air fronts that are moving, air masses that are moving, as it's falling, it's warm enough for those ice crystals to melt into large droplets. But when there's a hailstorm, it's because there's a major updraft of this warm air that blows these melted ice crystals back up high in the air to refreeze. And as they refreeze, they get heavy and they fall down. They melt a little bit and then get blown up and freeze again. This cycle can be repeated many times until that hailstone becomes heavy enough, because it's large enough, that the wind isn't strong enough to blow it up higher anymore, and gravity pulls it down. And the air at the surface is cold enough to keep those hailstorms frozen. So cold, warm, cold, and we've got an updraft cycling of airflow, freezing and refreezing of hailstones. Some hailstones can be as big as softballs, and you do not want that landing on your head or it would kill you. Lots of property damage can be done in nasty hailstorms. But that brings us to the final type of precipitation called freezing rain. If you're a driver, this can typically be the most dangerous type of precipitation. Warm, warm, cold are the words. It can be warm enough in the cloud that it's liquid, warm enough in the atmosphere that it looks like it's raining out, but the ground is so cold that when that liquid water, those drops of rain hit the ground, it freezes instantly, creating what people call black ice. Very dangerous to drive, very dangerous even to walk in. Lots of people get injured by walking or driving in black ice caused by freezing rain. So again, I want to encourage you to be watching weather reports. Look at those weather maps. Try and draw some of the symbols that you see. Here's a weather map right here with some different symbols. You can see the H and the low for high and low pressure. You see this line here with triangles on it. What is that all about? Well, I'm about to tell you, and we're going to finish up with these symbols here today. When looking at a weather forecasting map, meteorologists do use different symbols. Some of the symbols that you will see on a weather map include a line with triangles on it. I like to draw the line with the triangles facing down rather than this one here with them facing up, because to me it looks like icicles hanging off a clothesline. And icicles hanging off a clothesline reminds me of a cold front. So if you draw a line with triangles on the bottom, that's like a cold front. The next one, it represents a warm front, and I do like to draw it this way with the half circles above, because to me it looks like the rising sun. The rising sun means it's getting warmer, and so a line with half circles on it are representative of a warm front, a warm air mass moving in. The next one here is a combination of the triangles and the circles, both pointing in the same direction, which represent a stationary front, means the two air masses are bumping into one another and they're not moving. And finally, what's called an occluded front, or a kind of a mixed up front, one moving over another, with the half circles on one side and the triangles on the other side. So we've gone over a lot of information today about weather. Tomorrow, we're going to focus on just one aspect, and that is the humidity of the air. And we're going to measure the humidity in the air tomorrow using a psychrometer. So be sure you got all those notes for today. And tomorrow, we're going to have some fun using a psychrometer to measure how humid the air is in this room. So until then, I'm going to say bye-bye.